Coming up on this episode of the IoT Inc. Business Show.
Is it just semantics, or is there a real difference between artificial intelligence, AI, and analytics? Between machine learning, ML, and AI? Between deep learning, DL, and ML? And between analytics and DL? Well, it depends on how detailed you want to go. In this episode of the IoT Business Show, I speak with Bret Greenstein about using AI and IoT and how it's different from using analytics.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is for business leaders and managers employing the Internet of Things for their business or the business of their customers. I'm your host, Bruce Sinclair, and I interview the industry's leading authorities to find out how they use IoT to improve business and create value. If you like this show, subscribe to it on iTunes and go to iotinc.com to check out my complimentary articles, videos, meetups, and webinars. Turns out there aren't that many experts in AI applied to IoT. So it took a while, but here's the first episode of the mini-series on the topic of AI and IoT. If you enjoy this podcast, consider funding it by becoming a Certified IoT Professional by completing the IoT Inc. Certified IoT Professional, or ICIP, online training program. It pulls together everything I know on IoT in the 3 courses in the program: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details about the ICIP program can be found at www.iot-inc.com/training. And with that, I give you Illuminating the Enterprise's Dark Data with AI and IoT with Bret Greenstein. With me today on the IoT Show is Bret Greenstein. Bret is Global Vice President of Offerings for the Watson IoT unit, where he oversees IBM's portfolio of products and industry solutions. Bret and his team help clients design, build, and operate connected things. Bret, welcome to the show.
Thank you so much. It's really good to be here.
So I read somewhere in the material that your PR folks sent me that IBM considers enterprise IoT, or the market, enterprise IoT market, to be $200 billion. Does that ring true? And what does it mean? What does the enterprise IoT market mean to you?
Yeah, it rings true, and it's probably larger than that. I mean, the real opportunity for businesses is every aspect of our business is being changed because of connected things. And I think for us, as we look across the industry and we look at how vehicles or manufacturing equipment or buildings are being transformed because of connectivity, all of that connectedness, all of that data, all of those insights are now basically changing the things people build and the way they operate their business.
Sure. So then when we look at the 200 billion, what does that represent? Does that represent the incremental opportunity when connecting those things? Is it just identifying the markets? Because on one side it seems small, on the other side it seems big.
Yeah, there's multiple pieces to it. There's clearly a sort of technology, sensors, devices, connectivity layer of that. And while that's very necessary for IoT, the real value and most of that value is coming in the implementation and the transformational benefits of building out IoT around your business. So take, for example, a retail store. You might put 100 or 1,000 sensors in a store that's going to cost you X once. But implementing a new flow in your store, implementing new training patterns for your store associates, optimizing inventory levels in your store, there's a lot of service work that goes into that. There's a lot of applications, a lot of analytics that go into it. That's where the real value comes in. And that's the kind of stuff that is where I think you're seeing the market size really accelerate. And so we look at it as devices, platforms, applications, and transformation. The bulk of the IoT market is in applications and transformation.
And transformation, is that another way of saying services?
It is, but it could be services a client does for themselves, or it could be services we do for them. Mm-hmm. They're generally doing it because they're saving money or generating new forms of efficiency and revenue.
Okay, so the enterprise IoT market is of 200 billion is what IBM sees as the opportunity to, what you just said there, sell products. I can't remember the whole thing. Products, applications, analytics, and services.
Exactly. So huge benefit in the applications and services and transformation layer.
Now, what is not the enterprise IoT market?
Primarily the consumer IoT market, mm-hmm. and also which includes a whole set of devices, a whole class of things people see, in stores that you could buy today. So if you go to Home Depot and saw smart lighting, that's cool. It's IoT. It's not the enterprise market.
And industrial is a subset of enterprise in this definition.
It is. So enterprise could also include what you might do in your own buildings and facility to operate your business differently. Uh-huh. Industrial have a much stronger focus on manufacturing and major equipment type categories.
Right. So this would then include both let's say the equipment and the services for, like you said, putting it into your facility, but also maybe putting it into your products. And then I guess in both cases it would be both under the same umbrella.
Correct. And you would look at the whole enterprise market as including, for example, what you might do for IoT in a connected car, just as much as what you might do in your own conference rooms or your own warehouse to operate your business. So we're getting to deal now very much with a client, both in their back office and how they run their business differently, but also on the products and services they sell and making those IoT-based products.
Now, how would you define digital transformation, and more in particular, it's kind of a jello-y word, but what is digital transformation with respect to IBM and with respect to IoT? Maybe kind of sew it together for us.
So digital transformation is the larger topic, mm-hmm. and it represents everything companies are doing to become data-driven businesses. Mm-hmm. IoT fuels that.
Yes.
If you think of the data that makes up your business today, all of the unstructured data, the text and language and stuff people type, the spreadsheets and numbers and stuff that run your business. And now imagine connecting, 500 things in your building or 5,000 things in your building, as well as your fleets, your warehouses and everything else. The amount of data goes up by orders of magnitude. And so it enables you to have a much better virtual representation of your business and then to build insights around it. So I think to bring it home, mm-hmm. digital transformation represents moving from, it's very much like we did going from paper to electronic communications. It's now turning all of the data of your business, including the data that used to be lost that can now be captured because of IoT, and using that to run your business with greater efficiency. And if I can give you an example of that, mm-hmm. Any given conference room in your building or where you work generally knows nothing. You walk in, maybe the lights turn on, you use it, and you leave. Your building has no idea how many people were in there, what equipment was used, how long it was occupied, how many chairs were left unused. You can instrument all of that. And now imagine your job is to optimize conference rooms in your business. You could have total awareness of the usage, utilization, equipment failure rates, quality, even the happiness of people in that conference room. You could know all of that and make much better decisions. And a truly digital business is instrumented and built on the data of your business. And because of IoT, there's data that can be almost every part of your business now.
Yeah, I like it. So if digital transformation is capturing and transforming that data, mm-hmm. What other data are we talking about in addition to IoT? Is it just IT, or is there other data so I'm just wondering, what else is under the umbrella of digital transformation in addition to IoT?
So if there were no IoT, mm-hmm. There's still an enormous potential for digital transformation built around instrumenting your websites and around capturing your operating data as well as your IT data. Yeah. IoT is giving you that extra level of insight by instrumenting the things that make up your business as well. And so if you run a warehouse, you could manage based on inventory levels and ERP and all that. So you can do all of that. That's still pretty good. But when you add on top of that sensors that tell you when how many crates are stacked over here, or the vibration of things as they move from point A to point B, you become total awareness of your efficiency and your safety and your losses that occur in a warehouse. So to me, IoT just takes it up, 2 more levels of instrumentation and data and insights. But I think all of us have been on a journey since we ran business with paper. We've been on this digital journey. Now it's being supercharged because of this IoT insight that can be gained.
So I guess that is the 2 sources of data. Then, websites even being a subset of IT, I guess in some way if you squint your eyes. Yeah. So we're talking IT and IoT. We're talking about we've been instrumenting the virtual, I suppose, is one way you can think about it. Well, maybe that's not a good way, but we've had the virtual data that's come in on the IT. You just brought up some good examples, ERP, all our different business systems. And now this is extending it to the physical world. So I'm not missing anything, right? It kind of is IT and IoT. Those are the 2 sources, or is there like a third one that we haven't highlighted yet?
Well, there's a ton of. So it is, I guess, everything you could lump under IT, but there's a ton of other data that's particularly interesting. We use, for example, a lot of the unstructured data that makes up your business, the words, the language, the documents now can also be understood thanks to some of the technologies in AI. And so I would say that was possibly IT because it's captured in an IT system, but it has not been used until now. Okay. And so there's a lot of untapped. Sometimes we call it dark data that represents all aspects of your business. Some of it comes in through IoT as a device, but other parts just exist within your business. And we need to capture all of that. Truly digital business would know not just that your users filled in a survey, but how they felt based on the words, the tone, the meaning. And then if you add context to it, they happen to have been in a place where the weather was bad, the lighting was dark, and they had a negative review. That might be different than people who are giving you reviews from a very happy, warm, sunny place. Mm-hmm. So you might have a better understanding of your users, for example, if you could capture the unstructured data, the meaning behind it, and even the context around it.
Yeah, kind of like the metadata, right?
Exactly.
Yeah. All right, one last definition, and it's related, I guess, to the seemingly shift of brand on Watson. Mm-hmm. Is IoT a superset or a subset of data science?
That's a great point. I think IoT represents a very broad category of technologies, mostly around connected things, which then generate data and generate engagement for users. Data science takes that data and brings value to it. Mm-hmm. And so understanding it requires a whole new set of skills. And what I'm seeing among our clients is the emergence of new roles. Chief data officer. I see data scientists moving up and getting paid a lot of money within our clients as they're beginning to take advantage of the digital transformation. Chief digital officers, head of digital transformation. These are all roles that are all related to data science. And it becomes because a digital business only has meaning if you can get value and insights from all of that data. What does this mean? What does it mean that nobody used that conference room? Or what does it mean that 5,000 people use your product but don't use features A and B, but they all use C and D? What does that mean to how you build a product better, how you deliver higher customer satisfaction, how you optimize even the user experience of your products? And so I think there's tons of patterns and insights to be gained that only a data scientist will be able to capture.
Absolutely. And, my view is, and everyone listening has heard this before, but all incremental value of an IoT product, system, environment comes from transforming its data into useful information. And so there has to be that transformational part. And, if you look at Internet of Things just on the surface of Internet, focusing on network things, focusing on the physical, so maybe the instrumentation. Yeah, that's data capture. That's a data capture mechanism. It's a networking mechanism, but you need that second part. And that's why I like the emphasis on Watson. And we're going to obviously talk about AI and how they relate to the analytics. But why don't you tell us about your background in IoT?
Okay. I have a very long history of technology background, working in just about every aspect of technology. But more importantly, I've had this passion for automation since I started my career. Always working on things that drive new automation, new integration, new levels of insights. I feel like I've been on my own digital journey my entire career. And it's both a hobby as well as my job. And so for the last 4 years, I've focused very heavily, specifically on the Internet of Things, working on our IoT platform and working how we engage developers and how we do asset management and smart buildings and smart cities. And I'm fortunate to get to work on sort of every aspect of our IoT business. But the thing that I'm most proud of is that I was one of those people at the beginning who wanted to bring together AI and IoT. And my feeling was that IoT itself has an enormous potential just to help make things work better. Like a disconnected thing can work fine, and when it breaks, someone notices and they fix it. If you can connect it, you could know when it breaks and even before it breaks and prevent it from breaking. So a connected thing should operate much better if you put the right process around it. That's one value. And then there was the value of all of the data coming from these things telling you more about your users. So I was very excited about how IoT first made things work better. Second, gave you better insights about the environment and the contextual space around your business process or your users. But the third thing that I felt that was really important was to engage with users. So a connected thing can talk to you. A connected thing can interact with you in a way that can deliver better service to you. And so that's where we started to bring in AI to drive that kind of interaction. So, for example, if you put a camera in a refrigerator, you could see what things are in there, which things are expired, which things are running low, and deliver new value and new services through a refrigerator that was completely aware of its contents. That's a cool use of AI for machine vision, and a cool way to bring really good value to end users. And we found that there was once you start connecting things, tons of opportunities to understand images and video and sound and voice to deliver new ways of engaging with things. And so to me, that was one of the things that I thought made IoT move from saving money to optimizing a business to generating entirely new ways of engaging with people.
Yeah, and I like I was looking at the two different parts of the P&L. I like the saving money part, sure, the bottom line, but when you're talking about the innovation and invention, and that's where AI could play a pretty big role. But I want to step up just one level, and you've already started answering this, but this is new to the podcast. We want to bring in AI into the fold, so to speak, to understand, again, its benefits to businesses. So before we get into the Venn diagram of AI and IoT, let's talk about AI and business in general. And you kind of, one thing that I've heard is that you can think about AI as in a way of the senses, and you kind of said images, videos, sound, and voice. But the question is, where is AI being effectively used in business today? And then my follow-on question is going to be, with respect a little bit more focused to IoT. But first, what are the categories? What are the categories for AI and business in general?
So in the broader sense, I think where people have been applying AI successfully, because it has a wide range of applications, but is in learning systems where you can't prescribe in code, in a hard set of rules, what data might mean. And so that has applied really nicely to unstructured data, images and video and voice and people's personality and tone. These are things that can be trained from large data sets, even trained from small data sets with a narrow scope. And it's stuff that's very hard to write code around and prescribe from a hard coded perspective, but can be learned through data and sampling. I think we've already seen where people have been able to identify patterns and understand and look for things within business data. But I think the most interesting cases for AI in business have been around understanding this unstructured and dark data that represents much of your business. And this is where I think companies have kind of captured the imagination of people through the idea of being able to talk to systems, to have hands-free environments, to overlay images with context, on things like AR applications, for example, have some interesting uses of AI to understand what they see. Mm-hmm. We've applied AI in manufacturing, for example, to do image analytics and video, so we can help inspection for quality in manufacturing. Now, I started my career in doing visual inspection by hand, and I would look at things, and if I saw a defect, I would flag it and send it off to a different basket. That's how I started a very long time ago. Now we've got AI systems that can be trained to be the very best of all the operators, and then help the operators to find things they might have missed, to operate with greater efficiency, to never get tired, and then also to improve over time as more issues are learned. So I think, looking at just one example, image recognition in manufacturing, huge potential. The other area that I found really interesting was a really good engineer can walk through a manufacturing line or an oil rig and just by listening, tell you what's going on, what sounds mean, what things are breaking. So we've been able to do acoustic analytics using machine learning. We can train it on different types of problems to listen for. And you can think of this as taking the very best of a 40-year engineer and boiling it into a set of AI models and algorithms that can be used to make everyone as experienced as that person and give them the kinds of insights they might have missed. And I think that's what a lot of people, they give too much credit to AI in the sense that it does what a 40-year person does when they've worked on something. But in reality, it can be trained to catch the things that experienced people might catch, and to find some things that they wouldn't, but to help everyone else to get advantage of that experience.
Okay.
And you can and it translates further into text. I mean, most of our businesses run on text. Mm-hmm. The requirements documents that describe how to build a car are filled with just text. Make it do this, don't do this, and understanding that text and turning it into rules and turning it into insights is powerful. Your customers in any business give you enormous feedback, most of which is tossed away. Every time you're on a phone call and you're calling customer service and you're angry or annoyed or frustrated, the best you get in most cases is a call center operator who puts a little checkbox and says, Tom's a little annoyed. But you lose all the context. Mm-hmm. But in theory, with an AI supported system, a call center could become incredibly intelligent, learning from the interactions, helping guide you to avoid problems. So saying, it sounds like he's getting irritated. It sounds like this is like something else that's happened over here. Don't say that. Say this instead. Help people instead of annoy them. And so I think the uses are quite broad. And that's why I touched on image and video and sound, but they're very, very broad applications from call centers to manufacturing to really just talking to people. Using AI to help understand them.
No, I agree. And I guess where I'm kind of stuck is, to a certain extent, when I start reading about AI, and even so far in our conversation to a large extent, I can substitute AI for analytics, and I can substitute analytics for AI. They're almost homonyms in this case. And so what I'm trying to understand is the difference between where you use AI versus where you use traditional analytics. So analytics are based on statistics or statistical models, and I guess we're going to jump in there a little bit. But that's kind of where my dark matter is, and that is, okay, everything I'm hearing is like, well, you brought up something, the contextualization, understanding text there. Okay, that's going to be tough to do with an analytical model. Feedback from customers, maybe, but a lot of what you're saying and a lot of what I read, I can interchange them, right? With analytics and AI. So maybe give us what's the difference here?
I think of analytics, and there's a lot of definitions, but I think of analytics as the broadest category. Okay. It's gaining insights from data, and there's many techniques to analytics. Mm-hmm. There's something as simple as doing a query where I have a prescribed hypothesis that if I look for X and Y, I'm going to find Z. And so I can write queries and generate reports. And to me, that's the most basic form of analytics, is simply looking at the data with an assumed pattern. And you're putting in the hard work of describing that pattern in some sort of query. Mm-hmm. Very, very basic. There's more advanced techniques around big data, but they're still taken from a hypothesis and prescribed from a person into some algorithm. You describe what you think is going to come out. The difference in machine learning and AI, and I'm going to just kind of blend them for a second, but the difference in an AI-based system is that you're really talking about training a system by providing examples, by giving feedback as to whether those examples represent good or bad, and getting answers that are based on confidence, and they're not prescribed. I don't know what the outcome is going to be. If I train a system, for example, on images, and I feed it 50 images of a car, I'm describing it only by feeding it information and giving it some boundaries. And then the next thing I send, it's going to be a car or not a car. And it might even know what kind of car based on how much data I fed it. But for me to write an algorithm that describes a car is an enormous amount of work. And so there's a certain class of problems that are better solved, better analyzed through a training model than a prescribed model. And that's where AI has been most beneficial. There's probably much more academic definitions that blur the lines even more. But from a practical sense, things I can train, I use AI. Things I can prescribe that I might know what I'm looking for or have at least a way of describing what I'm looking for, I might use more traditional analytics methods.
I like that. No, I like that. And I think training is a good one. And you kind of were getting their experience, experience and wisdom, is another way of looking at it. And like you said, a very seasoned engineer can walk underneath a bridge and say, there's something wrong here, whereas analytics would be, you have to go and measure the sounds and you build the models and you compare them. And, it'd be like a junior engineer that'd have to go open his textbooks and go on the web and do all the calculations. So I get that, but I like the training. So what we're talking about here is what you're saying is AI is kind of a subset of analytics. It's just one type of analytics and I'm paraphrasing, you correct me. So it's one type of analytics. And the types of analytics are models, and within that type of analytics are models. It's really good on training-based models where you don't know the outcome and where you're not prescribing it, you're having to train it. Right. Am I kind of paraphrasing it properly?
I think you are. And I think most people have this misconception that you just sort of turn on the AI and it figures everything out. But there's a feedback loop that goes into training. Yeah. And that feedback loop is done by experts. And I can tell you that's a car or not a car. And then if I give you enough of them, eventually as well as I do that it's a car or not a car based on the training. And there may be things that are even unanticipated outcomes that you start maybe catch some patterns. But I think people overestimate this idea that you just turn it on and it just becomes, aware of what a car is. There's a feedback model here. And the reason that's so powerful is if you think of all the store associates that greet you at any given box chain store, imagine if you had some of the very best in customer service and trained an AI on the best customer service that could be, and then you gave little, earbuds or Bluetooth headsets to every store associate. As they're engaging with people, they should get the experience of the very best and then make decisions on what they're still going to do with it. But it elevates the experience level of everyone who can use it. The same thing with that visual inspection. I can be trained and you can be trained, and I might catch a defect, you don't. But if I can have a system watching and suggesting, Bret, don't forget, this is potentially a defect, then I can say it is or not. The system gets better, and I got better because I got some guidance and help.
Mm-hmm, mm-hmm. And the way I would before having this discussion, the way I would have done the defect is that we would have a statistical model that looks at the, let's say the assembly line product from all different angles, and then it compares the image with the different angles and then does a statistical regression on how close the images look. And I guess what you're saying is this is because you're training it, it's a more efficient way of doing. I suppose you could do, or maybe you correct me if I'm wrong. What I think and my understanding right now is you could do almost anything that you can do with AI with analytics. It's just not as quick, or are there corner cases where that's not true?
I don't think it's true anymore. And I think what's really evolved is the expectations on what a system could do from an analytics point of view is much harder. There's simply no way within a foreseeable future that you could describe every aspect of a car such that you could run images through. I took a great class on digital processing back when I was in college, and my teacher said, no matter how much calculations you do, nothing can focus an image as nice as a nice old analog lens. You just turn to the left and it's focused. It's incredible power of just focusing something, and yet calculating how to focus something is incredibly hard. Now imagine trying to teach a digital image system how to recognize a car from a truck. How many rules would you have to put in to do that? How long would it take? And it's not a hard problem. You could teach a child a car from a truck in 5 minutes, but to programmatically describe that in a digital imaging system was very, very hard. But training it by feeding it 1,000 or 10,000 images is not that hard. And so there's just a class of problems that are better solved with AI than any other method.
Yeah, and I think that's a key one. If we want to look at this, this podcast is focusing on the business aspect of the technology. And if we want to look at it from a business perspective, then something that everyone's listening now has to consider is this training. So like you say, people maybe underestimate the amount of training that has to happen, and they maybe overestimate the scope of what the AI can do, because that training has to be relatively narrow. So there is this whole, the underbelly of AI is you need lots of good data, and you need to be able to train. You need that data in order to train the AI to basically give it that intelligence. So is it a freshman in university, or is it someone that's been 30 years on the job? That data is needed. If you don't have that data, then the AI isn't going to go too far for you.
That's right. And it is also a layered problem. So there's some data that's common to every business. So that's something that IBM or some other company can train AI on basic things. And then you can also get more specific. Like we've done a voice-based system, for example, and we've trained it on not just the common language of helping people, but also we train it specifically on automotive knowledge, like what's a gas filler versus a gas. Sorry, my metaphor fell apart there. But where you fill up the car. Yeah. There's a million ways to describe it. We taught it the language of that. We taught it the language of tires and air pressure and fuel and stuff. Once you train it, every car has basically the same knowledge. It's different by country, so there's some localization, but you can do that, and then you get very specific in a given car model where they might have a very specific name for their stuff. That's where we can do narrow training. But you might find that collectively as an industry, there's going to be more and more reusable models. There's more and more data sets that we can all borrow from, where the training is not from scratch every time anymore. That's, I think, what's really shifted over the last few years is there's domains of knowledge that are more common that we can all leverage, and then we tailor it to our business.
Yeah, and I think you said the operative word in there is the layers. So, and that's again a different way that AI processes the problem is through these different cognitive layers, for lack of a better word. And some of those layers, like you're identifying, can be used across. I got a truck AI, I got a car AI. So you could probably use one of the layers for both, but then as it narrows the more layers, then it specializes. And is that a good way to think about it?
It's a great way to think about it, yes.
Yeah. All right. Well, let's pop up a little bit, and then so where is AI being effectively used in IoT today? And what's it good at? Because you've kind of alluded a few times that it's good at certain things. So getting back on track for AI in IoT, where is it being used today effectively?
A lot of great ways. I really like the text analytics that's going on. So we're doing a lot of work on understanding, for example, maintenance records and maintenance issues for complex assets, understanding requirements for engineering products, and knowing, for example, if you studied all the specifications of building a car, you could tell if the specifications have inconsistencies, gaps, conflicting requirements, things like that, that it takes an experienced engineer to read pages and pages of documents to find that. But we can train our services to go look for those things because there's a common language of requirements. There's this great student out of Stanford who trained Watson on parking issues, and so it's a parking law. And it's this guy named Josh. And what's really cool about it is it's a very prescribed set of law. And when you have a parking ticket, he created an automated approach using Watson for an appeals process. What I liked about that was by programmatically doing it, but with a trained system where he trained it on the parking rules, the appeals are generated in a very consistent way. And my understanding is that one of the towns even wrote back and said, we love your appeals because they're all so consistent. So instead of having everyone make up their own appeal and make up their own interpretation of laws, he trained Watson to do something that a lot of people needed, which was to fight parking tickets.
And I understand, just to follow it on a little bit, I understand that, his system was successful in, I don't know, the number, 70% of the cases, because he could find little loopholes. And law, like you said, is rules. And if you can then understand the text and then contextualize those rules into models, then you can find where the holes are. And so, it was very successful, where people would just sign on, I think, to his website, put in a situation, and then get some direction, and usually able to fight their ticket, right?
Right. And it's an amazing example of how, since all of our businesses are built on rules and policies and structures, but it's a lot of words, having systems that can comprehend words and patterns and rules and help is great. Now, imagine if you also had cameras in cars that could properly identify parking spaces, and even more, read the signs to know the rules, to know that this is exactly the right time or wrong time. I don't know about you, but when I go to a different city, I can't follow the parking signs because the rules are so complicated. I don't know if I need a resident permit. You never know. Imagine if you had AI that could read the signs, look at the maps, understand past history of parking violations, and maybe just prevent you from parking in spots that would have gotten you a ticket in the first place. So the potential, I think, for visual systems to understand signs it can read, indicators on roads, warning signs, danger, construction, anything, can be very powerful, whether it's in a parking situation or visual inspection for manufacturing. So a lot of the IoT use cases have been putting not just a camera in manufacturing or a connected car or somewhere else, but to understand what the camera sees and to use it for some outcome. That's been very powerful. We even have a drone company that we're working with called Aerialtronics that was using Watson to understand the images seen through the drone to know if power lines were having problems or not, defects and issues on power lines. And it was a safety thing. It prevented people from having to climb and look from different perspectives.
Yeah, and I think we're kind of narrowing a little bit onto what are the best use cases for AI in IoT. IoT being the instrumentation of the physical, being the physical world. We need to sense that world. We sense it with different types of sensors, and then using just our sensors being how we see, how we hear. I guess that would, maybe there's some other ones, how we feel. That would be, those seem like we're all good candidates for AI in IoT, to understand what I'm seeing, to understand what I'm hearing, to understand physically, whether it's through actuation or something like that, what I'm feeling.
Absolutely. So we just announced in the last week a project called Watson Assistant, which takes for business the kind of conversational interfaces people expect and be able to put them into hotels and into appliances and into cars. So we can engage with people. You can talk, or you could text or chat with a thing and get answers and get help. And we can build into it the ability to understand your feelings and your emotions. We have tone analytics and personality assessments and all kinds of conversational techniques to know, are you frustrated? Are you happy? And what are you looking for? And so I think we should all expect that these connected things in our lives are going to engage with us and allow us to interact, get help. You should be able to go into any car, especially a rental car, and just say, what side of the car do I fill up the fuel? Or what does that warning light mean? And get a very specific answer that's in context, that's current, and helpful. And and the car company, the fleet, should know, this guy's getting a little bit annoyed. He keeps seeing red lights on the dashboard. I can tell he's annoyed. How do I provide better service to that person? So this idea of interacting with our things, which kind of started in the consumer space, is very strong in the business space, because there's so much value if I can engage with you and get you to communicate with a thing, with an appliance, for example. Imagine how much insights I could have and how much more service I could deliver, how much better experience I can create.
Yeah, no, and that's kind of, interacting with the physical world through a digital interface, and then interpreting that data. That seems to be a sweet spot. That seems to be, because that's what you normally hear about AI. You hear image recognition, audio, you brought up a couple here in terms of tone of voice, maybe, and that could be, recognize the personality, the emotions from the tone.
Yep.
And this again, the common denominator. I'm trying to squeeze this into something that's recognizable. But at least a one way of looking at it is if your AI system, product, environment, whatever the case, is interacting with the physical world. Those are all touch points: talking, seeing, hearing. They're all potential touch points that AI could improve things. Yeah,
certainly. And think of the insights you could have for the last 100 years. Every washing machine ever made was shipped into a house, plugged into a wall, and you never heard from that customer again until they bought another one 10 years later. In the world we're in now with IoT, you're going to connect that to your Wi-Fi because it's going to give you some extra feature. And from that moment on, the customer and the manufacturer can be engaged in some way. You can learn about your users, what features they use, what they care about. Do they use it more during good weather or bad weather or whatever? All of this to help you drive better experience to those end users. That's a level of insight those companies have never had. No relationship at all. So,
yeah, but you're talking more generally. You're talking, and I want to weave the AI into that. So if we weave the AI into that example, because that's IoT and that's analytics, makes total sense.
Yeah.
But what you're saying here, then, okay, so if there is that washing machine, AI is really good for things that you need to train. I don't know, we're just using that, or that you need to sense. So we talked about maybe talking to that washing machine.
Absolutely.
Maybe listening to it. From
what about a camera inside that tells you put a red sock in with a white laundry? Like you could understand what's going in, you could understand the sounds around it, you could understand the people interacting with it. It's an enormous. It's like the richest set of insights about your customers you could ever have.
But again, I want to separate between AI and analytics. So separating the two of them, these are things we need to. There's a whole slew of information we can get, but where we apply AI versus where we apply analytics would be in the case where you're training, don't put reds with whites, or, don't put so again, I want to just go down one level and try to understand this because, we can do a lot of what you're talking about with analytics, but with AI, we are talking, just trying to, again, form something here, sensing, interacting with the environment, and training. It seems to be
I agree.
From our short discussion so far,
I agree. If you look at image, acoustics, and voice in that washing machine example, we train systems to recognize red sock versus something else. We train that, and that's the AI aspect of that. Now, when you look at what all of that means, the insights about those users, there's probably more traditional analytics techniques you can use to understand what it meant. Like, people put red socks in the laundry on rainy days. I don't know. That could be something you could just get from a query as compared to a trained aspect of it. But I think it's the combination of connected thing, which is the IoT part, with AI, so you can sense and understand through a trained set of models around what's happening with the thing. And then there's all kinds of insights you can get through traditional analytics to understand what to do to better service your customers.
Yeah. All right. Let's identify what exactly is AI. So for everyone listening here, or we have some real technical folks listening, of course, but we've got also lots of managers, executives that are listening. So what is AI? What is it? A software library? Is it a development environment? For example, IBM or Watson, when you sell AI, what are you selling? What is the thing that you're selling?
We're selling a set of tools and methods that help people to train and then to manage a system for that. It could be as simple. We have a whole set of things. We have a set of APIs, for example, that can be fed different types of data. Some of them are trained out of the box. For example, we have image recognition APIs that out of the box can tell you tons of things, cat, dog, car, all kinds of things. And then it has tools around it so you can train it with more data to make it a specific model for you. Okay. And so we'll have, and we mentioned those layers, right? We'll have stuff that's a layer that is common and then a layer that is trainable. So we have the ability to have a runtime as well as a training tool to help you train and manage and build out those insights. And then we'll also have a management system that allows you to deploy and manage those models across things.
So then I'm hearing three things. Then, at least in the case of IBM, there's a suite of tools that allows you to train the AI.
Mm-hmm.
Then there's a set of APIs that allows you to execute the AI within your product system environment.
Yeah.
And then, oh gosh, and then I just forgot the third one.
Well, there's also a set of domains and knowledge that we've already prescribed.
And this is the data this is the data layer that you're talking about. One of the data layers you're talking about.
It's more than a data layer because we use the data to train, but we create domains. Like one domain might be customer care. We've trained, and we've already done this. We train Watson on the language of customer care as a starting point to enhance a call center, for example. And so we've trained it on the basics of customer care. You may want to train it on the specifics of customer care in your business, but that's the way it works. And so we have these domains of knowledge that are pre-trained. We have tools to extend that training, a runtime to be able to deploy and use those models.
Okay, and then the operational part of it, where does that play in, or does it? Is that just part of the application code that the customer writes?
No, and then we also have hosted systems that can actually execute and run that for you. So in the case of Watson Assistant, for example, we have all those things we just described. We have basic set of domain knowledge, a set of tools and methods to help you tailor and configure it. But we can build an assistant that goes in your car, or you could build an assistant using our tools. And then we host and run that for you. So right from your car, let's say you're a car maker, you can have that assistant in all of your cars. And it has a runtime component that can exist inside the car. We have a little bit of an edge functionality as well as cloud-based functionality. And your entire runtime solution can be running for all of your customers. So everything from the tools and the domain knowledge, the APIs for development, and then, of course, the runtime to operate it.
And the runtime to operate it, what you mean is there's going to be, you're going to program
a hosted instance
into your application. Sorry, Go ahead.
Well, think of it as a hosted instance of a trained AI to do a specific function for you. So if you wanted to train an AI specifically to be an assistant in a car or to understand the camera in a drone, we train it, you build it, but then you're going to need that to be running all the time so that every drone in your company can send their images to this one runtime environment and get the insights you want. Or every user of your cars can talk to and interact with the car, and there's some dedicated instance for you that has your data in it that manages that experience. So is that clear?
Yeah. So let me just sort of peel it back a little bit more. So we've got the API that we're going to access the calls that are going to access this knowledge base. This knowledge base, you're going to provide some of the layers, and others you're going to provide tools to allow the customer to develop those other layers that make it more specific for their domain. Then we've got the execution. The execution code we're going to run either on the edge, which is going to run locally, and this instance that you're talking about is going to be the combination of both the API, I guess connecting to the analytics world, I would say the models, and I guess we're talking about the same thing. So this instance you're talking about is really the method of connecting the application with the AI models. Yeah, am I getting that?
You are. It's your trained API for your particular use case, which is running just for you. And so it's really important if you're a manufacturer and you had visual inspection, you're going to train an AI to understand defects in your manufacturing line, or train the AI to be able to interact in a car with a person. Whatever that is, it has to run for your business. So it has to be there and hosted and available so that your other applications and your hardware can interact with it for your customers.
Yeah, and that being there really means that you're developing a custom model, AI model, that does what you need it to do. And
that's right.
In your case, you're helping it along. And in fact, they could just use it out of the box, and that model would be as intelligent as you can make it for their particular domain. But then you provide the tools to make it more intelligent, and then you provide that runtime environment, that being you're going to use the API to call, but it's going to be what we're really talking about here. I guess the brains part of it goes back very similar to analytics is you're creating unique models, and these models then are interrogated by the APIs that you provide to then output the insights for the customer's need. Yeah,
that's right. Exactly.
Okay, good. I'm getting somewhere. You're not getting anywhere because you know this stuff. I'm getting somewhere because I'm starting to learn it. So I appreciate that.
It's such a fun topic, and it's an intersection of so many things. And I think that's when you started with digital transformation, I look at it and I think, okay, IoT is one enabler, AI is another enabler. There's many others. I think for companies that are really born digital, they are building their company around these principles and around these technologies.
Yeah, absolutely. So let's end with some best practices. Now, IoT is new enough as it is. Now, using AI in IoT is even more bleeding edge. So, Bret, why don't you share with us some of the best practices that you found? And the angle that I'm looking for is, okay, it's someone listening to us right now and they're going, oh, wow, AI, I should investigate this for my business. What do they do? How do they approach this? We've talked about the cases, sort of, I muddled my way to kind of get to a place where we're trying to classify what the problems are that AI can solve. But what's your advice? What do you offer to everyone listening now when they're just approaching this from the beginning?
I think one of the first things that I've seen companies do that was quite effective was to really embrace data scientists. And I'm working with quite a few companies where they've given the data scientists a fair amount of latitude to innovate and experiment, to look at the business itself and to see how they might be able to innovate with that data. And so in a lot of ways, the webmasters during the early .com era were kind of in the same boat. They had this ability to just go do stuff rather than going through the formal IT process. And I think you got to get the data scientists unleashed. So I've noticed a lot of newer college hires, a lot of newer hires being brought in who have this point of view. They understand machine learning. They understand the power of data and insights. And you got to give them some room to innovate. So that was one. The other thing I saw was a cultural shift, that the leaders in a lot of companies are coming from more traditional engineering backgrounds, hardware and mechanical and electrical, but you've got to become sort of this data-driven, software-driven business. So I think finding people who recognize digital transformation and giving them some ability to influence product design and customer engagement and gain insights into how stores operate. You gotta. So you got these data scientists, but you got to have people who are thinking about business models and implications of data. The other thing is, and I've noticed a lot of online education now available through multiple means on machine learning and AI. I think we should be encouraging even business leaders to be taking some of these most basic classes, because they frankly don't really know what AI is other than what they've seen in science fiction. And it causes an unnatural reaction, either too much enthusiasm or too much fear, without realizing that the sweet spot is actually the value. And they should be looking for the value in this and not worrying about the extreme cases that don't make sense. But that comes from a lack of understanding. And so I've seen business leaders go off and take 2 weeks of class and go just learn. And I think it's very valuable. The next thing to think about is data privacy. There are so many things available now and tools and methods and stuff, but they don't all protect your data. And what people are missing, I think, if IoT introduces connected things, AI introduces the value of the data, and it is the lifeblood of your company. At some point, someday, there'll be a new measurement for financial performance, which will be tied to your data and your insights, not just your assets. And I think it's really coming fast. And so, and you can see it among startups who are valued based on the user data they have, for example. So I think this idea of putting privacy first and making sure your company is thinking about the privacy policies they have, what services and cloud services they use, and whether those services protect your data is really important. Because right now, there are AI systems where your data is owned by those providers, and there's others that are private. You got to think about that, because you're putting a lot of your company's value through these systems.
Well, you're making the point that the data is an asset, and so you need to protect that asset, and that's privacy being one component of the risk that you need to manage around it. And again, what you're saying here again applies very much on the analytics side, but I don't think there's anything unique for AI in this for that thread with respect or in comparison to analytics, right? It's pretty much the data, and that data, whether it creates an analytics model or whether that data creates a AI model, it's the same kind of same discussion, isn't it?
Yeah, it is. It is. And I just think it was one of those things that it's becoming a bigger issue because the value of the data is growing. the value of the AI is growing. And I don't think companies thought about that when they started experimenting with some of the, the publicly available AI systems.
So what I have so far is kind of a scary thought, but unleash the data scientists. That has interesting visuals. So they have, but it's a good one. So they have room for innovation. A little bit of a cultural shift, and again, we can talk about this, for analytics as well. But it's a data centric view of the world, and hardware is there to collect data, to process data. Software is there to basically process it. Analytics is there to process it as is AI. Education, I agree with that. And so educate yourself, make sure you understand it. And this is one small contribution to that education. And then similar to analytics, you're saying, but be careful because we're going to be creating data. We're going to be creating metadata, and specifically these models that we're going to be creating are assets. And so you need to make sure that you protect both the original data and the models. By the way, digital twin. So make sure you're protecting your digital twin. By definition, being the models and its raw data, because they're a big asset. They're important, and they're going to become a more and more important asset for your company.
I agree.
Does that summarize what
it does? It does. I think all of those are great ways to get on the path for AI. The only other thing I'd add is for companies who build products, the moving into IoT means moving into being a software-defined product, and it means that your product is not going to stay static after you shipped it. You're going to have a constant stream, hopefully, of updates, new features, patches, fixes, et cetera. And so you have to think in sort of an agile software delivered model in addition to a product delivered model. And I don't think a lot of companies have set themselves up for that. I talked to one company that made a connected product, software driven, cool appliance. And I asked them where their data goes. And they said, well, we didn't have a server, but there was another part of our company that had one. So all the data goes there, and they don't look at it. And I'm thinking, you just put all that energy into building a connected thing, and you didn't really consider that data would tell you how to fix your product and make it better, what features to enhance, and they were missing a whole upgrade cycle they could have done.
Yeah, no, you're preaching to the choir in this case. That's definitely my point of view. In fact, when that's the wrong way of looking at it. It's not about the sensors. It's not about the networking. It is about the data. And so you have to look at, well, it's more for the value. What's the information we need? What's the data we need to get that information? And what's the technology we need? And then packaging that, in my view, the digital twin is the first technology you start with, because it defines, again, your data science, strategy. It defines what data you're going to be collecting, and then the models that you're going to be producing. That's going to be used by both the analytics. That's going to be used by the application code, and whether or not it's going to be an AI one or an analytical model is really doesn't matter in this particular case, but you need to be thinking about it from a software-defined point of view. And,
exactly.
We're in violent agreement on that one. Tell us a little bit more about IBM's Watson or IoT Watson. Where can people find out more about it, and maybe just give us a little bit of a little summary of what you're doing there with Watson and IoT and AI.
Yeah. So there's a lot of places to look. Obviously, the website, ibm.com, www.ibm.com/internet-of-things. It's a great place to look about from a product perspective. But I think following us on Twitter, hashtag IBM IoT or hashtag Watson IoT, really, really fun content and stuff, because we're at a lot of events. We're talking about a lot of topics. And I think following us in those places is really helpful as well. And in general, meeting us at events, at hackathons and other places, you'll find our Watson IoT brand and just kind of covering a lot of parts of the globe. We do a lot of hackathons and events for developers, as well as major events like CES and Mobile World Congress and places like that, and where we have really, really good demos and good examples of what we have. And then for anyone who's traveling in Munich, we do have a worldwide headquarters for our IoT business, specifically in Munich. Not that it's a very cool building and a very cool place to kind of see everything all at once. But I just would encourage people to sort of watch for us. I think as a business to business company, maybe it's harder to see us in some places. But for those who really want to know about transforming business with Watson and IoT, the website and Twitter are great places to go.
No, I like that. Now, it's interesting, though, and I'm going to ask you, but most of where you were talking about seeing you, real techie. What about, are there are there business resources? And this kind of relates to your education, but are there business, where can people find out more about the business aspects of I guess AI, using AI and IoT, or is that maybe too fine pointed?
No, I mean we try to be pretty public through what we do in press and media and papers we publish on our website. Mm-hmm. So I think we try to bring a business perspective in addition to a technical one. I find that most people want more technical stuff from us. They're always asking us for more examples, more code. But from a business perspective, I think we have a really good solution focus. We publish and we produce solutions and packaged applications that help people to do these things. So manufacturing offerings, automotive offerings, we have hotel-based offerings for connected smart hotels and smart buildings. So all of that's available on our website and is work we do and also publish quite a bit, throughout the industry. And so I think in general, we're hard to miss if you're looking from a business or technology perspective. And we try to make sure we publish as much as we can.
All right. Well, I'm going to put those links in the show analysis notes. And with that, Bret, thanks. Enjoyed our conversation.
Thank you so much. I enjoyed it as well. And I look forward to talking again soon.
Okay. Well, that was episode 103. Don't like the number, but like the episode. To get an analysis of this episode, links to the things that were mentioned, plus the transcript, go to the show analysis notes, all of which can be found at iot-inc.com/podcast. If you've been enjoying this podcast, subscribe. That way you can get every episode delivered to your device. And there are 3 ways you can support this podcast. Well, maybe 4. You can share it on your blog, personal or company. You can share it on social. You can leave a ratings or a review on iTunes. To do that, go to iot-inc.com/iTunes. Only takes 1 click, or maybe a little bit longer if you want to write your thoughts. And the 4th way is, the podcast is free, but the way to support it financially is to buy the ICIP online training program. Of course, only if it's right for you. I'm your host, Bruce Sinclair. Thank you for listening. Until next time, may your path to IoT business be an intelligent one.
You have been listening to the IoT Inc. Business Show.